Every March, as the sun begins its slow retreat from the Antarctic sky, tens of thousands of emperor penguins do something that makes no sense. They walk away from the sea, not toward food, not toward safety. They walk inland, sometimes 50 to 100 kilometers across sea ice, toward the coldest, most exposed real estate on the entire continent. They are heading toward the one place on Earth engineered to kill anything that stays outside too long. And they are going there on purpose to breed. Almost every other bird on the planet times its reproduction around spring, when the world is warming and food is abundant. Emperor penguins do the opposite. They are the only bird species alive that breeds during the Antarctic winter, which raises the obvious question, why choose the hardest possible season to raise a chick? The answer becomes clear when you follow the timeline forward. A chick needs months to grow large enough to survive alone at sea. If the parents waited until spring to start, the chick wouldn't be ready before the following winter arrived. So the penguins reverse engineer the entire process, starting the hardest part first in the dark, so that by the time summer returns, the chick is ready. After courtship and mating, the female lays a single egg, and then something happens that looks almost cruel. She passes the egg to the male, balancing it onto his feet in a maneuver that takes seconds and cannot fail. If the egg touches the ice for even a moment, in temperatures this low, the embryo inside can die almost instantly. Once the transfer is done, the female leaves. She walks back to the distant sea to feed, and she will not return for close to 4 months. The male is now alone with the egg, and he will not eat again until she comes back. He tucks the egg onto the top of his feet and lowers a fold of skin and feathers called the brood pouch over it. A pocket so densely packed with blood vessels that it holds the egg at a constant temperature of around 36 degrees Celsius, an almost exact match for a human's internal body heat. Outside that pouch, the air temperature can fall below minus 60 degrees Celsius. Winds can reach over 190 kilometers per hour. For the next roughly 65 days, that thin fold of skin is the only thing standing between a developing embryo and a temperature swing of nearly 100 degrees. No single penguin could survive this alone, so they don't try to. Thousands of males press together into a huddle, and the huddle behaves less like a group of individuals and more like a single organism. Researchers using thermal imaging have found that the surface temperature at the center of a huddle can climb past 30 degrees Celsius, sometimes high enough that birds have to peel away just to cool down. Penguins on the outer edge take the brunt of the wind, then slowly shuffle inward as others rotate outward to take their place, a constant wave-like churn that has been compared to fluid dynamics. No one is in charge of it. There is no lead penguin directing traffic. It is coordination without a coordinator, thousands of individual decisions producing a single life-saving pattern, and they do this while fasting. By the time incubation began, the males had already gone weeks without food during courtship. Add the incubation period on top, and a male emperor penguin can go up to 120 days without eating, burning through fat reserves until he has lost up to half his body weight, all while standing nearly motionless in the dark holding a single egg on his feet. If the timing works, the chick hatches right around when the female finally returns, guided back across the ice by a vocal call so specific that she can pick her mate's voice out of a crowd of thousands. The male, starved and depleted, finally leaves for the sea to eat for the first time in months. But surviving the wait is only half the problem, because when these penguins finally do reach the ocean, they have to hunt in water that would kill an unprotected human in minutes, at depths that would be lethal to almost any air-breathing animal. Emperor penguins typically forage between 150 and 250 meters down, but the deepest dive ever recorded reached 564 meters, deep enough to put them well past the point where sunlight means anything. Most dives last 3 to 6 minutes, but the longest ever documented stretched past 27 minutes on a single breath. To make that possible, their bodies do something most animals can't. Before diving, they hyperventilate, loading their blood with oxygen. Once underwater, their heart rate collapses, dropping from around 70 beats per minute at rest down to as low as 3 beats per minute during the deepest, most extreme portions of a dive. That slowdown isn't panic, it's precision. Blood flow gets redirected away from the extremities and funneled almost entirely toward the brain and heart, the two organs that cannot afford to run out of oxygen even for a second. Meanwhile, their muscles rely on something else entirely, myoglobin, an oxygen-storing protein that emperor penguins carry in concentrations several times higher than a typical land mammal, essentially turning their own muscle tissue into a secondary oxygen tank. So by the time a chick finally hatches into the world, it has already been shaped by two extremes: a father who nearly starved to keep it alive, and a species whose entire circulatory system had to be re-engineered just to let it eat.